Hello and good day everyone. So in this Cisco networking series, I am focusing now on the dynamic route. The first one which I want to focus on this dynamic route is RIP. RIP stands for Routing Information Protocol. And this is one of the earlier routing protocol which can be used for dynamic route. See, earlier we have gone through static route. In static route, we need to define manually each and every route in each and every routers. Imagine if there are about 20 or 25 routers in an organization and updating each and every new single addition of a route or deletion of a route. It is a very tedious task. Whereas this RIP or the first dynamic route will automatically discover the routes. So this dynamic route will be very helpful in order to discover the remote, networks with help of protocol. So we will be discussing about this RIP in detail a little bit, and then we will also focus on the lab exercise. So here, when I say about this RIP, I'll discuss the parameters of this one. But before that, I will just explain about how RIP works. So there are routers in between. What you can do is that the networks which are associated with each and every, I will explain about how this routing information protocol works. Basically, in routing information protocol, it it is also called as a neighborhood protocol. What does it do? It has a distance vector algorithm. So what does it do? Distance vector real scenario. See, every router has attached networks and also remote networks. So what it does is that what we need to do, we need to define the router, all the attached networks, which also sometimes which networks wants to participate in routing. Okay, same thing. This router has, router A has some networks, router B has some networks. So after a period of time, like every 30 seconds, this distance vector algorithm, what it does, it sends to the neighborhood routers. So here, this router sends 30 seconds, after 30 seconds, all the routing information to the neighborhood, what we call as router. So thereby identifying the remote network of 10.3.5 is not available to this particular one, it will update the information. Similarly, after 30 seconds, this router also is configured for RIP. So this also transmits the 30 seconds to this, routing protocol, to the adjacent router. So then all these routers after a period of time gets automatically updated. So in this way, the routing information protocol really works in identifying the remote networks. So there are some important information like it has version 1 and version 2. Version 1 was the previous one where it can do only for what we call as a limited network scope where there is no CIDR. All classful, we call as classful. So here I'll show you about classful. Classful means the same net, it has the same CIDR across the networks. But today's networking protocol, we have only classless routing. So we use this version 2 because version 1 cannot focus on the what subnet mask. It doesn't recognize that subnet mask. Okay. So now in version 2 allows the use of variable length VLS subnet mask by sending subnet mask information with each and every route update. And one more important thing which we need to understand about this is distance vector. A distance vector algorithm. So this distance vector algorithm figures out the routes. So from A to B, B to C, C to D, as I mentioned that every 30 seconds, it basically recognizes and updates the routing table to its adjacent routers. So distance vector algorithm do not allow router to know exact topology of the network. It only knows about the neighbors. Okay. All routers just broadcast their entire routing table of out of all active interfaces on a periodic time intervals. Here it is 30 seconds. Okay. So I'll be showing the practical also. So here one more important element which you should know is the administrative distance. So administrative distance is a feature that routers use in order to select the best path, and there are 2 or more different routes to same destination from two different routing protocols. Like I can say, if there are two or multiple routes to the destination, it will select the cheapest or the easiest one. And also it defines the what is the performance, we can say. Like for RIP, the administrative distance is 120, whereas if you go for EIGRP, that is Cisco's proprietary protocol, enhanced interior gateway routing, it has 90, which is much performed, highly performed. Like you can see, for a static route it is 1, and the best example is directly connected. If you have a straight cable from point to point, it is 0. The only big advantage is that you have all the dynamic routes discovered. Okay, so I will just help you how this RIP version 2 works. So here RIP version 2 allows the use of, as I mentioned, distance vectors same as administrative distance and timers. So here router A, it has only 117.16.10.0. After 30 seconds, it updates to this neighborhood. Same thing, forward direction. Let me go through. It has now, this router 3 has 20, 30, 40 also. After a period of time, then this has 40 and 50. The routes which are there, it is coming. The other routes also shall come. 40 and 50 are the local. So once it updates, the reverse direction also starts. So almost all 10, 20, 30, 40, 50 are updated in almost all the routers. In this way, the discovery happens in RIP. But remember, there are a couple of limitations. This can have maximum of 16 maximum routers, which you can say. Yeah, I wish to mention once again, yeah, the RIP has only max of 16. That 15 hop is reachable, 16 is unreachable. I mean, what is hop? The 1, 2, 3, like that. The hop, okay. The number of routers in between from source to destination, these are called as hops. So it can travel only maximum of 15 hops. 16th is unreachable. Okay. So that is about one important point for the examination point of view. You need to remember, and also the design. Okay, so now let me go ahead in doing the lab. So I'm going to open this 3R. So this is the 3 routers which we have already done. So what I'm going to do, I'm opening the first router, New Delhi router, and here it has already powered on. You can see now, as of now, 1.0 is only 1.0, 2.0, all the 5 networks which are there. This router is connected with 1 and 2, whereas your London router is connected with 2, 3 and 4, whereas your what we call a Singapore router with 4 and 5. So now I just click this particular one, I add 1 and 2 network routes to this routing protocol RIP. So EN, I can say, okay, conf router, I can specify router what I want to say, RIP. Version 2, please do not forget to mention this version 2, and define the networks. Network 192.168.1.0, the connected networks only we need to write 2.0. That's all. And say write memory. Done. Same thing I need to do for London router also. EN, okay, router RIP version 2. You can use autofill also. Okay, network 192.168. See here, these are connected with 2, 3 and 4. I'm providing that 2.0, 3.0 and 4.0, and write memory. In Singapore, same thing I wish to do, EN star conf, okay, router RIP version 2, network 192.168. See the exactness, 4 and 5 are connected. 4.0 and 5.0 end. Okay, now the routes are done. You can verify now. Okay, I'm going to the desktop and say command prompt. Much easier than static route. So if I say ping 192.168.5.2, you should see a reply coming from 5.2. Okay, yeah, it's coming. Perfect. So it is pinging. So now there are some verification commands which we need to learn. So here I can say show IP route is one important command which we have already learned earlier. The same thing. So 1 and 2 are directly connected. We know that. 3, 4, 5 are R. R stands for RIP. This is the RIP route, dynamic route. So it has detected via 2.2. So the protocol has really helped us to discover the remote routes, remote networks. Okay, so like that you can even see in the other routers also. So first of all, I'll show you some important things. Like, let me debug the route so that what is happening inside I can really see. Debug IP, okay, array. So now the protocol is debugging is on. So you can see, yeah, it will after every 30 seconds. What will happen is you can, yeah, you see this one. What exactly is doing when debug is on? So it is showing all the what we call as here. You can see here. It has sent every 30 seconds some kind of notifications. So you can see one notification has been, this is how it sends to the remote. You can also say show IP protocols. This is one important command. So here, what you can understand is that when you say show IP, the routing protocol is RIP. This is how you learn how it is. So sending updates every 30 seconds, next due in 7 seconds. So invalid after 180 seconds, that's okay. And the interface also is informed, networks also is informed, and it is displayed. Here, one important thing also we need to understand that 120 is the administrative distance for this RIP protocol. It is standard, it is fixed. Okay, so this is how we need to understand about this RIP. Okay, so what I can, when I don't want to see this debug messages, I can say undebug IP RIP all. I can say all. Okay, it is turned off. Once again, you can see this show IP protocols, which will display you everything. And one more important thing before we sign off is that, like, we need to know about the multicasting IP of RIP. So the multicasting IP, I mean, what is multicasting? Basically, the router spreads or it spreads the network information through the multicasting in order to recognize the other routers also to get the routing information. So this is called as multicasting. Multi means it is not broadcasting. Broad means all. Multi is selected routers. Here in this case is neighborhood routers. So it does with the help of the IP called as 224.0.0.9. Please remember this is the IP which is used for RIP. 224 for every routing protocol we have a selected multicasting. So in this case this is the IP 224.0.0.9 multicasting. So that's all from me for this RIP, I mean routing protocol. Let me catch you up in the next protocol, that is EIGRP. Thank you. Bye.